we want to look at Newton's first law. And to understand Newton's first law, we first need to go back and visit Aristotle. And Aristotle put into place several concepts of motion. And one of the things that Aristotle had proposed, force was necessary for motion. And the idea that he had for a force was that a force was a push or pull on an object. He kind of said that these forces came in two different forms. There was like violent motion, which is when something does physically contact an object and move it around. His idea was that if you had some kind of sailing ship, the wind pushes on the sail, and this is violent motion. When I push on an object with my hands and it causes side-to-side motion, like anything side to side, is considered violent motion. The other type was natural motion. And this was motion that was an up and down. So this is, natural motion is why when you had a rock and you were holding a rock and you let the rock go, it falls to the ground. That was natural. So they had the idea that these forces were like pushes and pulls on objects, and the forces were necessary for motion. If you remove the force, the object comes to a rest. Can be thought of is if I'm standing here and I push an object on the ground, after a little bit, I push my chair will come to a rest and it won't move anymore. It seemed very, very logical. It had a lot of weight to it because a lot of observed things fell into this pattern. Now we need to wind the clock forward, 1,000+ years, is we want to bring in onto the scene Galileo. Galileo is going to do some experiments to study motion. The experiment he's going to do is take a plane, and he's going to put an object on his plane and watch it go down the plane. What he notices is as he increases the angle of the plane, the object is moving faster. It has a bigger V for the larger angle. V is larger, it has larger speeds when angle is large. So it starts at rest and it's moving faster at the bottom as he increases the angle. He also notices if he takes an object and it's rolling up, now he's going to roll it up the plane. As it goes up the plane, it loses speed faster if the angle is higher. So if it's moving up a plane, it slows down faster for a steeper angle. And then he does the following. He's like, okay, if I have some object and I let it go down, if it increases speed going down and it decreases speed going up, so this is increase, decrease, he thinks the next thought. If I had a level plane, would my ball roll forever? Going uphill and going downhill causes changes in speed. Does a level plane mean that my object should roll forever? And what he's trying to get at is force necessary for motion? And what he decides is there's a thing called friction. And friction is this force acting on the object that slows it down. He says that the friction is between the objects in contact, between his ball and the plane. He tests this by sanding down his plane. So he had these wooden planes, and he kept sanding and sanding and sanding and sanding to get them as smooth as possible. And he notices the more he sands, if his ball starts here and it has some initial speed, if it's rough, it would stop here. As he's smoothing it, it rolls farther and farther. This is smooth, smoother. And as he keeps smoothing the plane, it's rolling farther every time for the same initial speed. And this is why he comes up with the idea of inertia. And he is the one that says an object will continue in motion because that's what it's going to do unless something tries to stop it. And this is why he said friction is this thing that stops objects from moving. And an object wants to do what it was doing. if it was rolling along, it wants to continue rolling along unless something acts on it. If your object is sitting here, it wants to continue to sit there. And so Galileo's the one that actually kind of adds the concept of inertia and friction to the mix. Now what Newton's going to do is Newton's going to take Galileo's ideas. So what happens is Galileo basically undoes Aristotle. Newton comes along and takes Galileo's concepts, but because he has a mathematical framework, Newton's laws, and he comes up with the first law. And the first law is actually called the law of, it's known as the law of inertia. The best way to think of the law of inertia, an object at rest, or the most famous way it's known is, an object at rest stays at rest. An object moving at a constant speed in a straight line will continue to do so unless acted upon by a non-zero net force. So this is Newton's first law. It's the law of inertia. An object at rest stays at rest. An object moving at a constant speed in a straight line will continue to do so unless acted upon by a non-zero net force. And the reason that this part's in here, it's not just an object in motion stays in motion. It's an object at a constant speed, which means the magnitude of the velocity isn't changing, and in a straight line, which means it's not changing directions. So if you have an object moving at a constant speed in a straight line, it's just moving in one direction at a constant speed. It'll continue to do that unless some non-zero net force acts on it. And this is Newton's first law. An example of this, when you're driving in your car, you're sitting here in your car, driving along. In the passenger seat, you have your favorite physics textbook, right? Because everyone loves physics. And so you're enjoying your drive, right? You have your gas pedals and stuff. Suddenly, you have to slam on the brakes. So you're moving along, and everything in the car with you is moving along at the same speed. When you have to slam on the brakes, and you go from moving to suddenly stopped, you're attached in by the seat belt, let's say. Your physics book is not. So as soon as you slam on the brakes, you come to a stop with the car because you're buckled in. The book is not. So the car comes to a stop, the car stops, but the book was moving. And so the book continues to move because that's what it was doing, and then it lands up on your floor of the car. It continues moving forward because of inertia. It had inertia. It was moving with the speed of the car before you slammed on the brakes. The same is true when you're sitting at a stop sign. You hit the gas. What happens is you actually are sitting still. The car starts moving out from underneath you, and the seat catches you and propels you forward with the car. So these are just, some ideas of inertia. And you can actually see this if you get some kind of little truck with some wheels, and then you can you have some kind of loose item that can move around in the top. Put this object at the front, and then you push the car, that object would move backwards, right? Because the car starts to move out from underneath it. Or if you had that marble sitting back here, push both together, and then you put your hand here and stop the car suddenly, the ball would roll forward. So these are just examples of Newton's first law. It's the law of inertia, that an object at rest stays at rest, and an object moving at a constant speed in a straight line will continue to do so unless acted upon by a non-zero net force.